Okay, the next section here um, is about solving a formula for a specific variable. And being able to manipulate formulas is an extremely powerful skill to develop, and it'll serve you well across all of your classes moving forward, that are science-based, where you're going to see any kind of formula. Um, So it's important to recognize formulas and be able to manipulate them easily. So what does it mean to manipulate formulae and equations and solve for a variable? So equations and formulae by definition include two equated expressions. So here's an example. This is the area of a circle. And so this formula for the area of a circle has already been solved for A, meaning area is all by itself on one side of this formula. So A is by itself on one side of the equality. The area of a circle formula is convenient if the radius of the circle is known and the area is unknown. So you'll see on this side, you have unknown variables. I'm sorry. On this side, you have known, and the solitary unknown one is by itself on the other side. So what is unknown is all by itself on one side, and what is known, R, is on the opposite side. What if the opposite is true? What if the radius is unknown and the area is known? Then A equals pi r squared doesn't serve one well because the radius is not isolated on one side of the equality. So one needs to manipulate the formula using correct application of algebraic operations in order to maintain the equality of the formula. So let me give you an analogy about manipulating formula. So take, for example, the weight of one apple being equal to two small oranges. So here we've got a balance, and at the middle of the balance is where we have an equal sign. And the weight of the apple, of one apple on one side, is equal in weight to two of these small oranges on the other side. So you can see that they're even. So if one makes a change to one side of an equality and not the other, it violates the existence of an equality in the first place. So we want to make sure that we keep these weights on either side of the equal sign equal at all times. And so there's some things that you could do algebraically that would break that balance, that would break that equality. So for example, if you look at this example A here, if we were to add one orange on the left, so here we've got our original two oranges, here's our original one apple on the left, and if we just simply added one orange to the left-hand side, okay, that's going to break our equality. It's going to make things unbalanced. So we can't just simply add something to one side without breaking that balance. So it's no longer equal. Okay, another way that we can break the equality or break this balance is if we decided to divide the apple in half. So if we just simply divided the apple in half and only the apple, we left the two oranges on the other side alone, okay, now the left-hand side is going to weigh half as much as the right-hand side. So it's no longer going to be in balance. It's no longer going to be equal. So we can't just apply division to one side of an equation. But there is a lot one can do and preserve the original equality. For example, what if we added an orange, but we added it to both sides? So if we add one orange to the left and one orange to the right, as long as we did the same thing to both sides, it's going to keep everything balanced. It's going to keep everything equal. Likewise, if we divide both sides by 1/2, so if we remove half of the apple on the left and we had 2 oranges. So if we remove half of the oranges, we get rid of one, that keeps the balance, that keeps the weight equal. We could also double both sides. So if we double the number on the left and we double the number on the right, that'll keep everything equal and balanced. So we started with 1 apple. If we double that to 2, that's fine as long as we do that same operation on the right-hand side. So we started with 2 oranges. If we double that to 4, that's going to keep our weight balanced. It's going to keep our equation balanced. If what you do to one side, you do to the other. Now, what if we didn't work with apples and oranges? What if now we added something completely different? We added 2 lemons to both sides. So as long as what we did to one side, we also did the same thing to the other side. 2 lemons on the left, 2 lemons on the right. It's going to keep the weight balanced. It's going to keep that equation equal. Okay. So the key takeaway here is if you only apply an operation to one side, it's going to break the equality and you can't do it. Okay. But as long as what you do to one side, you do to the other side of the equality, you're going to be okay. So, if we kind of apply that analogy to manipulating the area of a circle example. So here's the formula for the area of a circle. And so if we made a change, if we added one only to the left of this equation, it's no longer going to be equal because we added something on this side, but we didn't add anything to the opposite side. So this equation isn't balanced. That is bad. Part B, so example B is, what if we divided A on the left by 2, but we didn't do the same thing on the right-hand side? That's going to break the equality, just like dividing just the apple in half, but not, oops, not there. But also like this, dividing the apple in half, but not dividing the number of oranges in half. Okay, that breaks the equality. The same is true here with this example. Okay, but there's a lot we can do to preserve the original equality. So for example, instead of just adding 1 to one side, what if we added 1 to both sides? Okay, as long as what we do to one side, we do to the other, it keeps the equality preserved. And that's a valid operation that we can do. If we divide both sides by 2, so as long as we divide this side by 2 and we divide the other side of the equal side by 2, we're A-okay. Here's another example. So what if we double both sides? So if we double the left-hand side, we also have to double the right-hand side, and that keeps this equality preserved. Finally, if we were to multiply by something completely different, so if we multiply both sides by 2w, that's fine. As long as we multiply the left-hand side by 2w, we also multiply the right side by 2w, we're going to preserve this equality. So now that I've kind of given you some examples of how you can break inequality and how you can preserve inequality in a formula or an equation, let's next look at an example.